will start by introducing the laminar flow fume hood and its controls. It has an emergency on-off, and unit has its yellow light as standardized for this type of clean room of the order of 1,000 to 100. We will introduce the fan and we'll introduce the yellow lighting. Each operating section of the fume hood has its own manual, so the user is advised to read the manuals to make sure he has the knowledge of each of the operating devices included in the fume hood. We are going to, for this particular demonstration, we are going to go to demonstration by using the IKo number 2, which is the middle IKo out of 3 units that are inside this fume hood. So in order to make use of the IKo 2, we are going to switch to IKo 2 out of the selection of 1, 2, and 3. That's for the AC current. And then for the DC output, you have an option of going to 1, 2, and 3. We'll stick with number 2 because that's the one that we are going to use for this particular operation. Now, it will have 3 IKo units that cannot be simultaneously operated, so whoever is in charge with any particular unit will have to make sure that unit's been that's been energized by an AC supply and also with the output of a DC current. Next, we are going to concentrate on the IKo 2 from its standby position. It has a cover to prevent excessive evaporation of the liquid. So, and it's also in a control box up position in order to allow the introduction of the counter electrode, the anode, the reciprocating anode, and the introduction of the part that needs to be electroplated. So we are going to remove the cover and expose the electrolyte. Next step will be introducing the reciprocating anode. For this particular test, we are going to use a 6-inch substrate. So the anode is designed with its wrapping, is designed to fit a 6-inch opening in a wafer holder. So we are going to take the reciprocating anode and install it to make sure that it contacts the leading pin coming from the control box, and tightening the anode, making sure it's tightly fit in the position. Okay, so the next step will be actually introducing the substrates. In this case, the substrates are 6-inch gold seed layer prepared substrate that come from the front-end processing. So we'll be using one of the 6 So the wafer holder is designed to enable positioning the 6-inch wafer within three dots grooved inside the wafer bottom plate. And in order to prevent the substrate to slide during installation, it's always advisable to put a single drop or maybe a couple of drops of DI water underneath, so you end up with the sticking effect of the thin layer of water that holds the wafer in position while installing it. Installation and handling of vapor is always done on this section of the fume hood, which is dedicated to installation and disassembly of the wafer holder. Always try to keep in mind to have, when installing wafer with the wafer holder, always keep in mind, try to keep the tightening the bolts in under 120 degrees, not 180 degrees. That way we will prevent the accidental cracking if something was not exactly well prepared substrate and there was some dirt under the wafer, because they tend to crack in a direct straight lines. So now a prepared wafer holder with the wafer inside is introduced inside the plating solution. Okay. And the console with the control box can be moved in that case forward. It's designed to allow this kind of processing and preparation, okay? So after moving forward, it's locked in with the 2 thumb screws, 2 butterfly screws. The test is to be done with a copper plating solution, which is run at room temperature. So we have already adjusted the temperature controller to be fixed at 30 degrees centigrade. We will start first the pumping of the unit, and the heating is not there because it's like close to a room temperature. Otherwise, the heat would come up if the temperature requirement would be, beyond 25 centigrades, 30 centigrades up to maybe 50 or 60 centigrades. But the controller will control the temperature within 0.1 centigrade. So before doing any powering the unit for the DC power, we have to make sure that we make electrical contact. So one contact goes And keep in mind, always it's dark black contact that goes to the wafer, to the substrate, and the red contact goes to the anode. So after starting the pumping, then we'll start the reciprocation of the unit. I'm cutting off the pump and cutting off the reciprocation at the end of the processing after a certain number of ampere minutes or ampere hours being used in electroplating of the substrate. Now we have to raise the control box to be able to remove the counter electrode, the anode, and the substrate, and to see what the results do we have of the test. Okay. So upon raising the control box, we can now push back the console with the control box to have a better access to the wafer holder and to the anode that needs to be removed. So we push this thing back. Now we have a good access to both, to the anode and to the reciprocating, and to the wafer holder with the part. The next step in processing is to rinse the part that's been electroplated, and that's done by introducing it into a counterflow cascade DI water rinsing. In order to save DI water, you may want actually a rough rinse with the DI water, just to remove excess electrolyte, and then introduce it into a counterflow system. Okay, and it stays there for up to 5 minutes. In order to prepare the unit 2 for the next processing or for the standby position, we need to remove the counter electrode, the reciprocating anode. The most efficient way to remove now the electrolyte from the counter electrode is to keep it vertically, because the material is a piled up material that tends to act with a strong capillary forces if the anode is being held horizontally. Vertically, it acts like emptying a beaker, and you can see how the liquid drains from that section of the reciprocating anode. To improve the speed, you may want even to squeeze it down, of course. Squeeze it out. That way you save the electrolyte. Since the level of the liquid in the plating tank can be varied up plus minus 10% without a significant effect on the plating of the plating results. Usually you have to make up with evaporated DI water anyway. So one way to do that is rinse your counter electrode with the DI water. And then if you wanted, you could also put it into a counterflow system to be rinsed for a longer period of storage. Otherwise, if somebody is going to use the same unit on a daily basis or on a weekly basis, the electrolyte that's been soaked into the counter electrode can be held there for a couple of days without any danger to the processing. It will dry up, crystallize. When you start processing again, it can be used continuously, continue the operation, whatever it was done. Of course, assuming it's going to be the same electrolyte. Okay, so at this position now, we can put the cover to the electrolyte, to the tank, and that way the unit is on a standby position for the next processing. Now we can see what we have done with our substrate that's been plated. Now, so we have actually exposed the finished plating product, the substrate, the wafer of 6 inches. That was originally a seed layer of gold. It's been copper plated to a level of about 10 microns, and it looks uniform now. It needs to be taken to an analysis for the thickness distribution in order to use that information to make the changes, if needed, in the tilt of the control box. The control box has 4 screws that adjust the tilt of the control box, so that if there is any indication that any section of this deposit is thicker, or there is a trend of some kind of a tilt in the deposition rate indicated by the thicker section and the thinner section, it can be adjusted by adjusting the to make it more parallel relationship between the anode and your substrate. The anode, the reciprocating anode, contains a wrapping cloth which acts as a dominant resistor, so that if there is an excessive tendency to plate one side without that kind of wrapping cloth, in the presence of wrapping cloth, it tends to minimize this effect of the distance control, and especially the so-called edge effect in the photolithography. So with that in mind, one, I repeat again, has to make sure to be familiar with the manuals for all the sections of the laminar flow hood, and it needs to be prepared with a wholesale test of every solution that's being used in this process, to make sure that the results that you see in the wafer holder, in the wafer, are not necessarily tied to the quality of the plating solution, but tied more to the processing and preparation of the photolithography. I believe this demonstration was helpful to the user and its colleagues, and they will be very successful by utilizing IKo Fibrotools technology to the fullest extent. Thank you.